Hi, my name is Differentiation, and my student ID is 2025268589.
Hello everyone, my name is Isra Abdul Fadil. My student ID is 202520314.
Hi, my name is Haikal Abdul Bakri, and my student ID is 2025294332. So, let's go to the video. Hi and Assalamualaikum. So let's begin with the first question. The first question is about the definition of the differentiation and what are the techniques for differentiation. So according to the University of Sydney Business School, differentiation is a branch of calculus that involves finding the rate of change of a variable with respect to another variable. In practice, this commonly involves finding the rate of change of a curve, generally a two-variable function that can be represented on a Cartesian plane. So a useful concept in differentiation is the tangent, which is a straight line that just touches a curve at any given point. The slope of a tangent at any point is the measure of the rate of change of the curve at that particular point. So there are various techniques of differentiation. So we just go through what we learned. So the first one is the definition of derivative, or we commonly call as first principle. This is the formula used to find the differentiation by first principle. The next one is the derivative of a constant, linear, and power function. When there is a constant, it will become 0, and when there is a linear, it will just go with the first like the first number, and the power is go to the front, and the power will be subtracted by 1. So this is the example. When there is a constant, it will become 0, and when there is a linear, go through, and then constant will become 0, and then this for example power will go down times in the front and minus 1, and then linear, and the constant becomes 0. So the next one is the derivative of the sum and differences. This is the formula for it. And the next one is the chain rule. This is a chain rule. The chain rule is where there is a two function at the same time. So this is the example for chain rule. But this is not a completed practice, but this is just the view of point for chain rule. So just the big one, we just for example, so the big 2 and this 1, 2 minus 1. This is the example. And the next one is the product rule. The product rule when there is a two function at the same time, but we cannot do it normally, so we use the product rule. This is the this is the formula for product rule, and this is the example. U is y, and then go it, we differentiate it, and it will become the answer. And the last one is the quotient rule. The quotient rule is used when you have one function divided by another function. There is a denominator in the function. So I think that's all from me. So let's continue to the next question.
Let's explain question number 2. Okay, for question A, the equation is y equals to ln x squared tangent x minus 3. This question we are multiplying two terms, so we use the product rule. First, we need to let the first term be u equals to ln x squared, and the second term be v equals to tangent x minus 3. Okay, so now we need to differentiate it. For u prime, we use the chain rule for ln, which gives us u prime equals to 1 over x squared times 2x. And after we simplify it, we get u prime equals to 2 over x. For v prime, the derivative of tangent is secant square, so we get v prime equals to secant square x minus 3. Next, we use the product rule formula, which is dy over dx equals to uv prime plus vu prime. So we put everything into the formula, and it will be dy over dx equals to ln x power x squared times secant square x minus 3 plus tangent x minus 3 times 2 over x. So the last answer, it will be ln x squared secant square x minus 3 plus 2 tangent x minus 3 over x. For question B, the question is y equals to x squared plus 1 over cos x. This question, we need to differentiate a fraction, so we use question rule. First, we let the numerator to be u equals to x squared plus 1, and the denominator will be v equals to cos x. So we need to find the derivative. The derivative of u is u prime equals to 2x, and the derivative for v is v prime equals to negative sign x. Then we use the question rule formula, which is dy over dx equals to vu primes minus uv primes over v squared. So we substitute our values into the formula, and it will be dy over dx equals to cos x 2 times 2x minus x squared plus 1 times negative sign x over cos x squared. And the final answer will be dy over dx equals to 2x cos x plus x squared plus 1 sin x over cos square x. So that's all from me.
Hi, see me again in the third question. So the third question is about given ln y plus cos 2x squared plus ey equals to 2xy, find the dy dx using the implicit differentiation. So what we need to do, the first one is we divide it with doing it one by one. The first one, this is the first one, this is the second. So the first one just ln y. So when we do it ln y, just 1 over 1. Second. And the next is the second. We use the chain rule. Which is this one goes up to the one, and then we will differentiate in this bracket. We will come it, and then differentiate in the bracket again, and we will come to this. So this is the question for the third, for the second, and next is the third, which is divided x to xy. So basically, just we use the product rule, which is u. This one is u, and this one is v. So u, v, and then differentiate between the two, and this one is x, and this is the question, and this is the answer. And after that, after we are doing the 2, 1, 2, and 3, so we go to the original equation, which is this one, right? 1, 2, and 3. So same 1 plus 2 equals to 3. So 1 plus 2 equals to 3. Like that. And then after that, we will do it one by one again. So 1 over y, and then this will become the blue one, and then this is the purple one, just like that. So we call it expand. Yeah, we expand it because this one, this is still the same. And then after that, after we expand all of those functions, and then we need to find dy dx. So we can the dy dx we put it in the left side, and there is no the function that there is no dy dx, we put it on the right side. So the dy dx is the highlighted, is the yellow highlighted. So we put it in the left side like this, left side, and then there is no dy dx, all of that in the right side. So after that, we factorize dy dx go out, and then like this, and then this one, all of this go to the right side, and will become a fraction. So that we simplify it. How to simplify it? This one we simplify it. This one we simplify it using the trigonometry identity. So how to use it? So basically we put this one, we go out. So then this one. So basically it's just a 4a sine a equals a, for example. So in the trigonometry identity there is such a sine 2a equals to 2 sine a equals a, which is same like this, right? If you see it, it is the same, but we need to factorize it first. So this one is 4, so we factorize it, it will become 2 and 2. So you can see right here, right? So 2 sine a equals a. So basically we can use the trigonometry identity, which is this one. After that, we change this one, go to this one, and it will become like this. So that's why my answer is this one, Yeah, so don't forget about the 2x is still there. So it's still the same with the denominator one, it's still the same. This one sine a cos a, so basically it's all the same. So this is the final answer for the question. So bye bye, let's continue to the next question. This is the last question. Bye bye.
It's my turn to explain question number 4, which is the linear approximation. Okay, for this question, that is to define a function f(x) based on the expression given. To do this, we simply replace the number 8.02 equal to variable x. Okay, first we must to replace it to fx equal to x square minus 1 over cube root x. Okay. To make differentiation easy, so we must to write the radical term using the negative differential exponent. So it can be x square minus x power negative 1 over 3. And then we can differentiation this. It can be f prime x equal to 2x plus 1 over 3x power negative 4 over 3. Okay. For next step, we must to identify the value. The x value we want to evaluate is x equal to 8.02. We need to choose a nearby integer, which is 8 naught. So 8 naught we can write equal to 8. Why 8? Because it goes with 8.02. And then we must to calculate the chain. So the chain formula is x minus 8 naught. So we replace it on the formula. 8.02 minus 8 equal to 0.02. Okay, for third step, we evaluating the function at the base value. So substitute our base value 8 naught equal to 8 into both the original function f(x) and the derivative f prime x. So we can write f x naught equal to f(x) equal to 8 square minus 1 over cube root 8. So we can calculate, we can get 63.5. Second, we replace 8 into f prime x naught equal to f prime 8 equal to 2 times 8 plus 1 over 3 times 8 power negative 4 over 3. So we can get calculate 7069 over 48. Fourth step, we apply the linear approximation formula to get final answer, which is the formula is f 8.02 equal to f x naught plus f prime x naught times chain x. So this formula we transfer all, we calculate above to this formula. X naught we get 63.5. So we plus with f prime x naught we get 7,069 over 48. And then we times with chain x, we get 0.02. And then we use calculator and we can get 63.820.
So that's all from us.
Thank you for watching.
Bye.